In the previous class, we were looking at some of the fundamental concepts of structural analysis. One of the things we spoke about is structures, what is analysis, and the thing which we came to a conclusion was that analysis is finding out the forces, the internal response of a structure to some external disturbance which it might undergo. So the kinds of internal responses which we see are shear forces and bending moments, and of course tensile, etc., all the other forces. And we also saw that there were certain kinds of elements which we have. In particular, we've got beams, we got columns, we got trusses. Any other forms? We got arches, we got cables, we've got slabs, we got tents, which are actually two-dimensional structures, and of course we also got solids. I mean, like, by revolving a curve, we can get some solids. Okay, so those solids like shells, domes are also structural elements. Like, instead of spanning a slab, you are spanning a arch or you're spanning a dome. Essentially, all those structures are purely take load purely by compression, so they are actually able to take large spans, much larger spans. Now, in this course, we are not worried about any of those elements. We are only going to go through beams. We are only going to go through beams. Okay. Now, first and foremost, okay, I'm just going to say that this is again some more fundamentals. So we will be again we'll be still going through some of the fundamentals only of analysis before we start one simple problem. Today, so that's the agenda for today's class. And so here we go. So we are looking at fundamental concepts. These concepts should help you uh, understand, or do better in whatever we are going to do later on. These are the foundations. These are the principles which I'd appreciate if suppose you use whenever we solve a problem. When you come to it, analysis is a very easy paper. Analysis is a very easy paper, provided you understand some of the concepts. Okay, first and foremost, it's something which is very elementary, and I have promised people marks for classroom participation. Okay, I do mean it, and for this purpose, I'm going to ask you guys to nominate three representatives. For this class, I'm going a little further. These representatives will help me track the marks. So those people should, it's out of their own personal integrity that I trust them, and I hope the class will also trust these people. Okay, so can I have volunteers first? Anybody will volunteer to be the representative to help me with this classroom participation marks? Sorry? Any nomination? Do you nominate anybody? Yes, he's my representative also in the G1 slot construction management. Think you can do it? Okay, Suyash Gupta. Okay, so thank you very much, Suyash. So the aim is that you keep writing down the register numbers. We both will form a template where you put it in Excel and send it to me so that I can update it in Moodle. Okay, so this is the funda with which we are working in this, right? Okay, so first question. Um, okay, now I'd like a person to define what equilibrium is. Okay, no issues. Take out your mobile phones, immediately Google up equilibrium, raise your hands and then answer. Google up equilibrium. Yes, you got the answer. Mm. Perfect. Uh, I will. Suyash, you are able to track them, right? These two this lady and gentleman. So please just make a note that they have answered one question. Okay, for each question you get marks. Okay, that's the way it goes. So here the internal and external forces have to be in equilibrium. Okay, suppose moon is hurtling at like some whatever million miles per hour or whatever is the unit you are measuring it with, you'll find that all the external forces that act on it and the internal forces that act on it, like gravity of the sun, the next planet, all the asteroids, everything put together has some sort of a equilibrium in it. Some dynamic equilibrium is there in that system. Okay, but for us, we are not worried about who is going to pull whom. We are only going to say that all the external forces and internal forces are going to be equated to 0. Okay, external forces and the internal forces put together are going to be equated to 0. So this is the most important thing which we are going to do. Now when we are going to have this particular state, we are going to state that this body is at equilibrium or is at rest. Okay, so as long as I am holding this pen tightly, whatever the rotation that this pen might experience because of its own weight and because of the nature of the support, you will find that it's not in equilibrium, it's still moving, but at one point it reaches a state where the force which I am giving here is able to balance the rotation. Okay, so this is the most of the fundamental thing which we look at. Another thing we are talking about is we talk about what is known as the rigid body. What is a rigid body? Sorry, as a point, but actually it's not two, right? Maybe you have not come across this word, which has space and mass, and also you'll find that it's retains its shape in the event of some, for example, you are having a rubber ball, you are able to press it, you cannot call that as a rigid body. Sorry. Yes, fixed. Distance between the particles will always remain the same irrespective of forces that act on it. Okay, so 1, 2, 3, 4 people, it's a little difficult to keep track, but please make a note of the numbers. Okay, you know the people, I hope. Suyash, roll numbers, you can just share your roll numbers. Fine. Okay, and one more person somewhere there, you told. Okay, fine, please make a note of his number also. Okay, now coming here, I'm sorry if I missed one or two of you, but this is the. I mean, this is. I need to go on with my points which I got for you. So, what happens is we are going to study rigid body mechanics here, in the sense that whatever is your beam, whatever is your column, the amount of deflection which it undergoes is so small that you can still say that it is acting as one piece. Okay, it's all acting together as one piece. Internally, if you look at it on a microscopic scale or on a nano scale or on an atomic scale, there is a huge variation, but for our purpose it's sufficient that we say that whatever we are working with acts as a rigid body. So it means if I am going to give a force on this end of the pen, whatever is the force which is being applied is getting transferred to the other side. Okay, now you will appreciate this when you are going to study a cable. A cable, when it's stretched, will have an appreciable amount of del L. So if I'm going to guide a rope, that means it's not only the length which is there which is going to be the thing which matters. When you do your calculation, you'll have to understand what is that extra del L which is going to come and then make some allowance. So if you look at many of the cases today, you'll find that it is more easy to suspend a weight and then keep the load, because that means it will automatically take into account whatever is the variation. Okay, or you can keep a spring which will ensure that you are able to keep that force. But of course, even a spring is not going to be very helpful, but it's only a weight which is going to be helpful. How many of you have noticed a weight which helps keep some sort of cables in constant tension? Yes. Railway electrification, excellent. Okay, you can pass a number on to Suyash over here. Railway electrification will have weights on the on the catenary as well as the contact line, so that it's always kept at a constant tension. Okay, so there that's an example to tell you that sometimes that rigid body mechanism need not always be there. So we need to think something to ensure that your tension is constant. Okay, now coming here, I'm going to again go to a very fundamental question or fundamental concept. Okay, we are going to talk about moments of a force. Moments of a force. When I say moments of a force, what is moments of a force? It's from physics. Okay, I just want a definition from physics. Moment of a force. The turning effect produced by a force is called moment of a force. Please make a note of them. Here, the self weight of my pen is causing a rotation. Suyash, the person next to you also gave the answer. I forgot to tell him. Yeah, you just make a note of him. Right. So the turning effect produced by a force is going to be the moment of a force. How do you calculate the moment of a force? Force into perpendicular distance. Excellent. Force into perpendicular distance. This the whole class gave. I don't know how to give the marks for all, but still. Yeah, blanket one bonus mark. Okay, so turning effect produced by a force is measured as a product of the force and a perpendicular distance between the line of actions of the forces. Okay, between the lines of action of the forces. What is line of action of a force? One person raise. He's. I am going to give you the chance. Please stand up and tell me what is line of action of a force. Okay, so that is the line of action of a force. Now I'm going to say that there's a, please sit down, perpendicular distance between the line of action of forces. Okay, now if I want to find out what is the moment about a point, okay, that means I have a force here, a generalized force here. There are many distances which I can calculate between this force, but what I'm going to do is I'm going to draw a line which is perpendicular to, I'm sorry, which is going to be perpendicular to this or the perpendicular to this point. So this becomes also coincidentally the shortest distance which is there between these two points. Okay, so actually you will find that you can say that this is the distance between the force and the point P of interest. Okay, I can keep drawing any number of uh, points and say that that's the distance, but what we are interested is the shortest distance, which happens to be the perpendicular distance between the line of action of the forces. Suppose I am going to have a force of 10 kilonewton over here, and the line of action, this perpendicular distance, is going to be 3 meters. The moment due to this force is 10 kilonewton meter. Okay, so whatever be the thing, it's just the product of the distance between the line of action and the point of interest. Right, now we'll go one more thing. What is a couple? Yes. Yeah, 1 minute. I'm sorry. There are too many things. He raised his hands very clearly, so I'm giving him the chance. Yes, please. Yes. Turning effect produced by. Okay. Okay. Yes, they cancel off each other. So it means when they cancel off each other, there's no translation which the couple produces. Sorry? The yes, net force is zero. Force is zero, but then there is still a turning effect. There's still a rotation. One, two, three, four. Okay, four people. You please make a note. It's going to be very difficult for that guy here to make a note like this. He'll not be able to follow my lecture. I guess I have to do something where a little few more people are there per row or something to help out on this count. Okay. So otherwise, you can have that buzzer system. We'll see what we can do about this. But still, this turning effect which a force produces can be seen in where all can you see this? Steering, car steering. I'll show you some of the places. Suppose, how many of you know what a cantilever beam is? No marks for this. Cantilever, what's a cantilever? One end fixed and one end is this one. Great. Now, on this cantilever, if I apply a downward force like this, okay, then there is going to be an okay, there's going to be an upward force over here. If you look at this, it has the making of a couple. Both the forces are equal, both the forces are opposite in nature, both of them are connected by something which is causing a perpendicular distance between them. Okay, so it essentially means that there is not going to be any translation effect. The whole thing is there, it's under the action of forces, but it's not going to move wherever it likes. Okay, so this is one of the key things which I'd like you to make a note of. Okay, now what do I call the blue force? The one which is in blue, I will call that as the applied force. I call this the applied force because I am applying this force on the system. This is the disturbance which the system is experiencing. This is the thing which the system is going to respond to. Okay, and this is going to be called as the reactive force or the reaction. Okay, so suppose we are in a class. If I say this is the this is the way I hope to keep it as a constant reaction at A. Now this is a vertical reaction, so I call it RAV. RAV. Okay, so it means that reaction at A which is vertical in nature, H will be horizontal in nature. Suppose moments are there, probably we can use M. Okay, so that is a sign convention which we will try to follow so that all of us are on the same plane. Okay, all of us do the same thing. All of us are able to understand each other better. Now, all this said and done, we are going to have support conditions. Okay, so this support condition is a very important thing in the sense that it determines the behavior of the system. For example, all of you will say this is not able to, no, this is just suspended by its own weight. Suppose I want this to act like a beam, you will automatically say I have something else which is here, or there should be a support which will hold it firmly in place, right? So this is the other important thing, the types of reactions which you can get. So can we have we gone through the types of reactions? I'm sure you've done the types of reactions. So what would be the first thing which comes to your mind? Simple support. Okay, so this is a simple support. Okay, then there's a fixed support. Overhanging is a type of beam. Overhang is a type of beam. Okay, fixed support, then right, a roller support. Hinged is nothing but your simple support. Okay, simple support can be hinged. I mean, you can call it as a hinge support, a pinned support, everything. There, the support. will not allow the body to move to the right, or it will not allow it to move upward. Okay, it will not allow it to move upward. Okay, now on the other hand, a fixed support, so this is support number one. The support number two will allow nothing. It will not allow, it will prevent a motion of this sort, it will prevent a motion of this sort, it will also prevent a rotation. So all these three are going to be restrained or constrained. These three actions cannot happen. On the other hand, a roller support will allow you to only take up forces in this direction. Any rotation which comes, yeah, chalega. Any fixed, any horizontal force comes, it will again be allowed. Okay, so this is the very important or fundamental concept which we have in terms of the supports. And I'd like to just show you. I mean, you guys know it. I'll just probably remind you that this support is offering two constraints. Okay, this is offering two constraints, horizontal, vertical. So I'm just going to say that any force in the x direction, any force in the y direction is going to be taken up by this system, and this fellow will take three types of forces. Okay, so it can restrain, any moment comes, it will restrain it. Any horizontal or any vertical force, it's going to restrain it. I'm now going to remind you of some of the principles of physics which you saw. X, Y, Z. Okay, so you got this coordinate system. So I am using my right hand for the coordinates. So it's called I'm calling this as a right hand system. So any force which is in the direction from my hand, in the direction of my thumb points, is in the positive direction. Anything that goes in the upward direction, positive Y. Anything in the third direction, positive Z. Now one important thing which we need to remember is that in your case you are only doing two-dimensional work. We don't have any three-dimension in this course. If you are going for an advanced course, you will find that there are forces also in the Z direction. But please remember, this is not something new to you guys, right? You have used matrices to solve three-dimensional stuff in engineering mechanics. Okay, now one more thing is the moment in the Z direction. In the Z direction, if I put out my thumb, the direction of the curl of the fingers will be positive. You guys have studied this in your Thevenin's theorem and stuff like that, okay, or whatever was the, I'm forgetting the name for that motor. Okay, so you will be saying that current flows in this, that this is the direction of flux. So many other things you have already done. You guys are great with other subjects. Please remember, we are applying it now for civil engineering. What is happening here is all the mathematical principles which you have studied is coming alive here. Okay, is getting alive here. You will find that if I'm saying that a deflection is negative, it's in the downward direction, you will feel physically that that is happening. That's what we are going to expect of you when you finish this course. So you are going to see how these mathematical equations which we have are going to come alive for our day-to-day experiences. Okay, in fact, if you remember, one of the things which I've told you is StatPro is mandatory for this class. StatPro is not mandated by the syllabus, but it's mandated by me so that you can see something come alive. You can cheat all your homework. All your homework is going to go ask for answers. It's up to you. It's your personal integrity which is going to, what should I say, make you do the hard way and then get the answer, or just use StatPro and give me the answers. I don't really worry much about all these things. But one thing is very important. Please remember that if you practice all of this, whatever I'm talking to you now, this mathematics which I'm talking to you now, will make more sense to you. Okay, so that you feel that you're not wasted 12 years of your life doing school. Okay, now coming here, the roller support is only going to give one constraint, obviously. So this kind of summarizes the uh, important restraints which we are going to do here. There are many other things. Spring, okay, spring supports can be there. For example, there can be partial fixity. Okay, that means it'll not be able to give full fixity. It'll allow rotation after a particular moment has got reached. Okay, then there are some of the supports which are friction based. So as long as the friction is within a particular limit, it will not cause any movement. But when the load exceeds a particular value, then it starts to slide. Okay, so all these are advanced things, but these are what happen. For example, if I'm taking a board, just a board, rough board, it's a rough board, and I'm keeping it on a rough surface. Till a particular point, it will not slide. Okay, when a person steps on a beam, so suppose there is a, excuse me, just let me get down a little. Right. So suppose there is a beam of this sort which is bearing on another support. Okay, this is bearing on another support. When this is having a point load in the middle, this fellow will definitely move to a point. It'll come to a slightly. It'll move. It'll have a translation because of this bending. Okay. Now till a particular point, it will not slide, but beyond a particular limit, it is going to slide. Okay. So that's what I'm trying to tell here. We are not worried about all those supports in this course. So it's very straightforward. The three supports which we saw is jolly good for us. Okay. Now I want to quickly start off with one concept. We got around 5 minutes. Or what I'll do is we will leave it for now with this. Okay, we'll leave it for now with this. Next class we are going to deal with free bodies. Now, free bodies are not something new. Free bodies are not something new to any of you. Free bodies are very common for you. You would have done it very commonly in your engineering mechanics. Okay. Now, I am going to, in the previous class, we had given a couple of problems. I am now adding to that. So, today's homework is, again, analyze this beam. Sorry. Analyze this beam. I'm just giving a point load in the middle of 10 kilonewton and 3 meters, 3 meters on both sides. Ignore self weight. Okay. Analyze the, draw the free body. Draw the free body diagram and completely analyze the structure. Draw the free body diagram and completely analyze the structure. Okay. So when we meet tomorrow, tomorrow we got a class. I guess it's at 2 p.m. Okay. Please be here at 2 p.m. I will leave you now. Please do this homework. Do you have any doubt in what we have seen, please? It's very fundamental. I'm very glad, guys, that you know these concepts. Okay, I'm glad that you remember these concepts. These concepts are only required for this course. I'm very relieved. Believe me, I'm very relieved because you know all of this. If you know this paper, teaching this paper is also easy. And from you, I expect a lot. All the best. See you guys.